Next, we're going to learn about simple harmonic motion. This is 2.5.3, and harmonic motion is our only vocabulary or rule or theorem in this section. So the motion of a weight bobbing up and down on the end of a spring is an example of simple harmonic motion. So we can imagine a spring weighed down with some sort of weight on that spring, and if we pull down on that weight, then that spring is going to stretch and be a little bit lower, and then the spring will recoil until it gets a little bit well high up the mark. And so we move from here to here, and then that spring will move down again and up again. And so it seems to be like a periodic sort of movement, and that's called harmonic motion. You might also see that in a pendulum of like a big grandfather clock, where the pendulum would move back and forth along or inside of that clock. So the next example is going to describe a case where there aren't any opposing forces, such as friction or buoyancy, to slow down the motion. So it's a very clean and sterile environment. We've got a spring and a weight on the bottom. So a weight hanging from a spring is stretched 5 units beyond its rest position, where its position at rest is s equals 0, and released at time t equals 0 to bob up and down. Its position at any later time t is given by s is equal to 5 cosine of t. So our questions: what are the velocity, what are the acceleration at time t, and then we want to describe the motion. So we know that the position s is given by 5 cosine of t. Let's talk about the velocity. So we know the velocity is the derivative of position with respect to time. So velocity is ds dt. So the derivative of 5 cosine of t, the 5 comes along as a multiplier. The derivative of cosine of t is negative sine of t. And so that means the velocity function is negative 5 sine of t. Let's move next to the acceleration. The acceleration, we know, is the derivative of velocity with respect to time. And so that means, let's see, derivative of negative 5 sine of t, the negative 5 comes along as a constant multiplier, and the derivative of sine of t is cosine of t. So now that means the acceleration is negative 5 cosine of t. And so again, the motion of the weight on the spring, it's going to be periodic, or what we call harmonic motion. We will start at a position of rest, and we're going to be pulled down and up and down and up and down. And so that motion of the spring will be harmonic.